We graph an absolute value function. You're going to use this formula. So it's plus or minus A. Okay? A for an absolute value is similar to the slope of your line. Now, with other things, whenever we get into parabolas and logarithms and rational functions and everything else, it's not really such a slope as it is a scale factor. Okay? So what did you notice about whenever it was a negative out in front? What happened to your graph? It flipped over, right? Okay, it was pointing down. It was pointing in a negative direction. If it's positive, like it normally is, which way is it up? It's positive, right? It's pointing up. It looks like the V. Okay, whereas if it's negative, it looks like an A without the crossbar in the middle. So whenever we actually graph this, okay, if it's negative, then it's going to be a reflection. Okay, so it's going to be a reflection across the x-axis. If you have A, okay, depending on what it is, so if it's bigger than 1, it's going to be what's called a vertical stretch. Okay, that means it's going to get taller faster. If it's basically between 0 and 1, if it's a fraction, okay, it's going to be a vertical shrink. Okay, so if you notice, like the ones, and you didn't have one as far as on your cards that were a fraction, you had a 2, which if you notice, it's a little bit thinner because it's pulled and stretched up. Okay. Then, like we talked about, it says if H is positive, so if it's positive inside of there, then you're going to shift it left. It shouldn't be B, but it actually should be the letter H, because I changed what it should look like. So here should be an H, and then here should be an H, and then this should be K and K. So if it's a positive K value on the outside, that means you're just going to go up that many places. If it's negative, you're going to go down that many places. Okay? As far as how we move the vertex. Okay? So whenever we actually graph this, all you're going to do, okay, you're going to look for the vertex. The first thing you want to do is figure out which way do I go, left or right, and then do I go up or down. Okay? It's always the opposite of whatever it looks like. So if it's a negative or a minus, it's going to go in a positive direction. If it's a plus or a positive, inside whatever we're dealing with, and this is going to be the same across the board whenever we do this, it's going to go the opposite, so it's going to go to the left. Only the K value or your vertical shift is going to be exactly what it is. You're going to take it for what it's worth. If it's positive on the outside, it's going to go up. If it's negative on the outside, it's going to go down. It's only on the inside with your X that it's going to be the opposite. Okay? Inside is always the opposite value. If it's negative, you go right. If it's positive, you go left. So then, if you look, just to kind of touch, we're not going to spend a whole lot of time here because you did most of it already. So like on example 1 where it says x minus 2 inside the absolute value plus 5. So what are we going to do? Is it going to get flipped? Is it positive or negative? Right here. Positive or negative, so is it going to get flipped? No, because it's not negative, so it's just going to stay as is. What is that negative 2 going to do? Which way is it going to go? Left or right? Right, how many? Right 2. And then what's that 5 going to do for it? Up 5. If you go straight down, what's the negative going to do right here? What's it going to make it do? Reflect. So it's going to reflect over the x-axis. What's the plus 7 going to make it do? Left, right, up, or down? Left. How many? And then what's the minus 14 going to do? Down 14. So how does this look whenever we graph it? What's going to happen? Flip over to the back side. Okay, let's go through 5 and 6 real quick. So with 5 and 6, I have 3 times the absolute value of x plus 1. So I always want to move left and right, up and down first, and then worry about the number that's out in front. So what is that plus 1 going to do for me? Where am I going to go from the origin? Left 1. And if you need to write it, write it. So I'm going to go left 1. Now, what's the 3 going to do? 3 is like my slope, so how would I graph 3 if it's in front of the x, if it was just y equals mx plus b? What would I do? Up 3 over 1, so up 1, 2, 3 over 1. And I'm going to do it again. Now, it's absolute value. So it's not a straight line. So I'm going to have something that looks like this here. Now, it's absolute value. So I'm going to flip it over and I'm going to go the other direction. So I'm still going to go up 3, but now instead of going right 1, I'm going to go left 1. So I'm going to go up 3 because all it's going to do is mirror each other. It's going to mirror the other side. So it's going to look like a V or an A, depending on what we have. Always move left, right first, and then worry about flipping it, or because you want to find your vertex first, and then worry about if we need to flip or if we need to vertically stretch it or shrink it. Okay? So now let's do 6. So if we do 6, or actually, how about you do 6? And then I'll let you check it. So you graph 6. Tell me what it does. Tell me, does it go up? Does it go down? Does it go left? Does it go right? Is it a vertical stretch? Is it a vertical shrink? Does it get flipped? Tell me everything you know about this function. So what did we do? We went right 2, down 3. So to get my vertex, so my vertex is at 2, negative 3. And then from there, so if we want to know what the vertex is, what did we do? We went with our slope, which was 1 over 2, so we went up 1 over 2. We did the same thing. We went up 1 over 2 to the right, and then up 1 and left 2 in that direction. Okay? Absolute value, and then whenever we get into parabolas, they're going to be symmetrical. Okay, so we could basically run an imaginary line through that vertex and either fold it over and everything's going to match. Okay?